Yeah, so, well, first I just want to say thank you to Codebar and especially thank you to Kimberly for setting all this up. It's can't be easy, and I think we get some really wonderful tutorials, sessions and everything out of this kind of event. And it's just a really fantastic job they've done. So yeah, so about myself, I'm Rowan. I'm going to be talking to you about Kotlin, a programming language that I've used quite extensively. Just a quick background on myself. I'm Rowan AJ Marshall on Twitter and GitHub. I've worked in tech for about 5 years now, almost pretty much all of that in London. I started out doing Java, since it was what I studied at university. I used that for a good 3 or 4 years, but for the last couple of years, I've been writing 90% Kotlin at Seed Eagles, and occasionally Java, but you can't have everything. We're going to be doing a lot of live coding here. How I'm going to do it is I'm going to give you an overview of the language. Then we're going to do a lot of live coding. That will be the bulk of this session. And then I'm going to leave a few minutes at the end for any questions and answers and that kind of thing, and anything else we want to follow up on. So great, yeah. Kotlin. So Kotlin is a statically typed language, object-oriented. It follows along the lines of something like Java or C# or sort of C++, more so than something like JavaScript or Python. It's developed by JetBrains, who are most famous for developing Intellij, which is like the IDEs, the integrated developer environments that are pretty much the best kind of thing to use for JVM. They also do stuff for Python, PyCharm, they use Ruby. They have something for almost any language out there. It was originally developed to run on the JVM, so that is, it compiles to Java bytecode. It's meant to run alongside Java, and that's why JetBrains originally developed it, to sort of help their own efforts because they wanted a nice language to work on. But I think it's one of the really underrated parts of Kotlin is it can run on the JVM and it does it fantastically, but it's not limited to just that. It can run on the web, so it can compile to JavaScript or WebAssembly. So that means you can use JavaScript libraries, which is just absolutely fantastic. You can even compile it to front-end code, write your HTML and CSS in Kotlin. You can compile it to native code, so that way you can get a few performance advantages, especially with startup times, and you can use C++ libraries, and you can use Kotlin libraries in C++. But I think where Kotlin is most famous for is Android. So as of about 2017, most people would use Java to write for Android. There was some cross-platform stuff, React Native, and then Google announced something, and it announced Kotlin as a first-class support on Android. And that kind of changed the game a little, because Kotlin really sort of brings a lot more modern features into where you would previously use Java. And as of 2019, Kotlin is now the recommended language for use on Android. You can still use React Native or anything like that. You can still use Java, but the first class support, the best support you're going to get is Kotlin, and that's what Google kind of encourages everyone to do. And well, we're going to go over the features in just a second, but if you want to cut it down to like a sentence, Kotlin it's basically Java rewritten for the modern day. It's Java with sort of some of the old cruftier stuff lopped off, a load new features added in, but retains all of that fantastic support that Java's really become known for. Okay, so I think that's pretty much the intro. We're just going to go over a few of these features here, and well, let's get coding. So we're going to start off on the traditional task thing here. We're going to go over a nice hello world. So we're just going to write up here a quick thing. I'm going to be using, like I said earlier, Intellij for this, the IDE written by JetBrains. You can use VS Code, you can use Eclipse, there are plugins available, but honestly, Intellij is the top way to go. It has fantastic support, and it really is just an awesome editor to use. And you can get, the full package can get expensive, but you have money off if you're a startup or if you do open source. And if you're a student or if you just want a simpler version of their IDEs, they offer all that stuff for free. So it's really worth downloading it and checking it out. It's just a fantastic developer experience. So we're going to start off with a nice simple main function here. And we're just going to print our old friend, hello world. And we can display this just by right-clicking here and doing run. And we'll see the output in the terminal below. So this tells us a couple of things about the language, especially if you come from, I'm going to be referring to Java a lot here. And that is, first we've got top level functions here. So there's no need to wrap anything in static, void, access, main, public, and all of that stuff. It's very simply, you've got a main function that gets called. This doesn't have to take a list of arguments from the program, but it can. And it's a slightly simpler way of doing it. And we're just printing in a hello world out straight away. No need for system.out.println, just println here. So let's go a bit further. Let's get a name out. So if we do val name equals Rowan, and let's just print out Rowan. I'm just going to introduce you to one more feature here before we discuss how variables work here, which is string interpolation, which is a way of getting data from a variable into a string without having to do a lot of concatenation. It's something that's I think it's a lot more readable, and it's simply, there you go. So if we run this now, then we get hello Rowan. It takes this variable and it inputs it in here. If you put brackets around this, you can do far more complex expressions. So now you can do name plus, I don't know, let's wrap that in a string. We can do complex expressions and bam. So it's just a really nice little feature there. What I wanted to go over is the variable and how we're handling it here. So the first thing you're going to see here is, unlike something like Java, although that has changed in recent versions, we're not declaring a type. We just say val name equals Rowan. The compiler is smart enough to work out that this is a string. So if we wanted to do something like here, you can see we don't need that. We can move our mouse over here and it says, yeah, this is a string. So it just cuts down a little on the amount of typing you have to do, and it just makes everything a bit cleaner. It is statically typed. This isn't like Python. It has a type, but we don't need to explicitly mention it unless it's a complicated generic setup. And the other is how we're declaring it here. So in Kotlin, there are two main different ways. There are a couple of others, but the main ways, there are two ways of declaring variables in Kotlin. The first is to use val. Now, this declares an immutable variable. So that's a variable that can't be changed afterwards. If we try to reassign this name to, say, Sarah, you'll see that we get a red underline here. And if we hover over, val cannot be reassigned. Once we assign a name to this, we can't change it. But if we do var, all of a sudden we can. Intellij provides a little underline to let us know that this is actually a mutable variable. And if we play this, let's just put this back in there, we'll see that it will just print out Sarah straight away. So I think this is part of Kotlin's effort to sort of move more towards a functional style of programming. It tries to encourage immutability over mutability. I think the general benefits from this is immutable code is easier to reason about. You know where this stuff is getting changed, and it's got benefits in things like multi-threading because you don't need to provide extra locks and stuff, and it's generally considered the way modern code and style is evolving. So that's encouraging immutability versus mutability. It doesn't prevent you from doing mutable variables, but it does try to encourage you in one direction rather than another. Great. So let's move on to a feature that pretty much every OO language has nowadays. Well, OO is almost defined by the existence of this feature. That is classes. So Kotlin supports classes. Their classes are pretty much the same as any other OO language fundamentally. That is a object that has data from other objects and has methods and can perform actions on that data. So let's have a nice simple val person who has a name, which is a string, and an age, which is an int. And if we create a person here, so let's create a Rowan, a whole new Rowan, we can pass in the name here, Rowan, and the age here, not age, 27, I think, for at least the next couple of months. And we can just access these variables just like you'd expect here. We can do, we need to use the complex expression here since we're accessing data within a class. We could do rowan.name and rowan.age. And if we play this now, here we go, Rowan27. Great. So yeah, I mean, there's not too much to say here if you're familiar with other OO languages. You can have methods in here, you can have data in here, you can change data in here if you declare any of these var. Here we go. And Kotlin doesn't mess around with this too much. It does add a few extras on that we'll discuss in a second, but classes are classes. Great. One little thing I want to say, and you can do this in functions as well, is that in Kotlin, we have named variables. So if we wanted to do it like this, that's just fine. But let's say we want to make this a little more readable, and we can do this out of order, by the way. We can say explicitly what we want each variable to be. So we can say age should be 27 and name should be Rowan. It's a small thing here, but it definitely helps, I think, with the readability, especially with massive methods or massive classes that take a lot of arguments. Being able to split it out like this and just define exactly what you're saying at each step, it saves you from clicking in and seeing what each one is, and especially if you're not using an IDE or anything, it makes it a lot more clear what data refers to what variable. Great. So I'm going to show you a little bonus that Kotlin threw on top of our classes, and that is data classes. So this is a concept that's become a lot more popular recently. I think even Java is introducing records. Python has had data classes for a while. I think in Scala has had them. They definitely features starting to catch on. And that's like a class, but with extra stuff. So we often need a class that contains a blob of data. Now, it won't perform lots of business logic on it. This is just meant to hold a lot of data in one place to make it more convenient to pass around. And this kind of class has some behaviors that we kind of want to do. For example, if we want to do toString on a class that we already have, let's try println Rowan and see what happens. So if we play this, then we get this output. I don't know if you can see that. I'll zoom in a little. And what happens here is we're printing out the type of the class, and then we're printing out the hash code. Now, this can be useful, but if you're just eyeballing it, it's not really. To make this better, you need to be able to override, I think, the toString method. And you can do that without a problem, but if you're adding variables and you want to see what those are in the toString, you have to remember to update the toString, and it's extra code that really you don't want to have to do. So what you can do is if you put data on here, just data, it doesn't change any other behavior, and we just play this, you'll see a much more sensible output here. Person, name, Rowan, age 27, no problem. And this just makes it a lot more clear when debugging, or especially in logs. And I think the other thing I want to go over especially is equals. So let's get rid of the data and let's create another Rowan here, because there cannot only be one here, there can be many. And we just pass in Rowan 27. And let's say we want to do Rowan equals Rowan 2. Now this can have different behaviors here. If we play this, we'll see this comes out as false, which in one sense makes sense. I mean, these are different variables referring to different Rowans. But if you've just got a dumb class that's meant to contain a blob of data and not really anything else, then this isn't really the behavior we want. If a blob of data contains the same blob of data as something else, maybe those are meant to be the same thing. And if we slap data at the start here and play this again, you'll see that all of a sudden we're returning true, because, well, these data classes, they're only holders of data. They contain the same data, so they should be equivalent. Now, traditionally, you do this by overriding the equals method. But again, once you add variables to things, you have to make sure to add it in there, and it's not the easiest way of doing things. This automates all of that with 4 characters, 5 characters if you count the space. And I think this kind of thing is really indicative of what Kotlin tries to accomplish. It gives you the tools you need. It means that you can still use classes the way you're used to, but it gives you extra tools on top just to cut down on the amount of faff. I hate faff. I hate faff in my programming, and this just hugely cuts down on the faff that you have to go through. And it's the kind of thing that the Kotlin authors want to go to, and I think they're doing a fantastic job of doing that. Okay, so I'm going to get into default arguments here, kind of similar to named arguments almost. Let's say we wanted to add a new variable on top of this. So let's say we were adding a new feature and we want to have someone's job. So we're going to do a val job, which is a string. Great. Okay, this is here, no problem. And even the data class will automatically include this job in the toString, and it will automatically include in the equals. But you can see a problem here. Our code's no longer compiling. If we hover over, no value passed for parameter job. We don't know what value this should have. And this is fine when it's our own code because we can set the job when we want. But if we were creating a library like this, maybe this isn't what we want. We want to add features, but we want to make them optional. We want this to be an opt-in thing. So what Kotlin lets us do is we can declare our val job string down here, and then we can assign this to empty string. So now we've got an empty string, and now this compiles again. And if we run this, then we can just print out, let's say, Rowan. And if we print this out, it prints out just fine, and it prints out job equals empty string. Okay, great. This is really good. This means that we don't have, we can keep things backwards compatible in a much more easy way. But I'm going to quickly move on to another thing here, null safety. It's a very big part of Kotlin. There's a lot to go over. I'll just go over the essentials here, because it doesn't always make sense to have a null job or an empty string job. We want to represent that there's an absence of one here. So we want to use a null. So if we want to default this to null, which is it's a sensible decision, I think, you'll see that our code here is fine, but our code here is all of a sudden broken. And if we hover over it, it says null cannot be a value of non-null type string. And this is because Kotlin does something very important. So getting null pointer exceptions or uncaught type errors or none types in Python, then, sorry, I just saw your comments and faff be gone. Totally agree. Faff be gone. You can see that it just doesn't let us compile. And this is because Kotlin splits, it defines nullable types that can be null and non-nullable types that cannot be null differently. So this is sometimes called the billion-dollar problem, because the amount of pain it's caused. Almost any programmer out there will tell you about null pointers messing up your servers. And in this way, it just lets us say what can have an absence of value and what can't. So the way we fix this in Kotlin is we can just put a question mark on there. And now this is defined as a nullable type, which means it can be null. And before we perform operations on it, we have to perform a null check. So let's say we wanted to access this job. Well, we can access name and age just fine because they're not nullable. They're mandatory. You have to have them. No problem. But if you wanted to access a job, then if we do rowan.job, let's say length, you'll see that we've got an error here. And that's because we're trying to access the property, a length, of something that could be null, which is a problem. And there's a couple of ways we can get around this. The first, that I'm sure anyone using Java would have seen plenty, just in case, we can just explicitly check for a null. So we can go rowan.job, or if rowan.job is not equals to null, then we can put this in here, and the compiler is smart enough. What is this? Smart cast is impossible. Oh yeah, that is because okay, this wasn't happening when I was testing things, so I'm not actually sure why this is happening, and I'll have to apologize there. What we're trying to access is prove that this isn't null. Oh, here it is. It's because this is var, and because I think this can change. So if we assign that to val, there we go, it's fixed now. We can see that this is another case why mutability is good, because if something's mutable, well, it can change. It could be null. We might not be checking the same value. If it's immutable, we know this is going to be the same Rowan that we assigned here, that we're checking here, that we're accessing here. And now we can just access rowan.job.length just fine, no problem, because we know it's not going to be null. But that's not really how Kotlin encourages you to do it. What Kotlin encourages you to do is something like this. You can do rowan.job. Now this is nullable, but if you hit a question mark, now you can access everything. And this is, I think it's something like the null access operator. And what this does is, if this is null, then it won't access this. The compiler won't throw a null pointer, but it will return null for the entire expression. And this just lets us if length could be null, we could chain all sorts of stuff together here. So we can do quite a complex expression without nulls appearing. Or we have to do the null check at some point, but we're not going to get it straight away. And I think this is one of Kotlin's really standout features here. It will save you so much pain. It'll save you all those null pointers, and it's just a great feature. It's definitely one of the killer features here. Okay, so enough about that. How about we go on to lists and perform an operation on lists? So this is definitely something that I use constantly, pretty much every day. We want to define a list of people. So here we can do list of. Great, so we've got one person in here. Let's just format this nicely and get rid of this. So we've got one person in here, age 27. We've got another person in here. Let's call them Oliver. And let's set them to 25. And let's have another person here. And let's call them Sarah. And let's say Sarah's a toddler, so Sarah is 3. Great. So let's say we want to perform some operations on this list. Now, you might be familiar with Java streams, which are an amazing invention and definitely make Java a lot easier. But they're a bit clunky. They're a bit awkward to use. They're definitely really hard to debug. Oh, and I just checked the comments, sorry. And yes, it is very much like optional chaining. Only in this case, it is encoded straight into the type instead of something that you should do. So it absolutely forces you to do this, although it will not compile. There are a few options to kind of get around it, but unless you really know what you're doing, you should probably not do them, especially in production code. Okay, so back to this. Yeah, it's very similar to Java streams, but just much better. Let's show you what I mean. So we have a list of people, and let's say we want to print out the names of all the adults here. So first, let's filter this list just down to the adults. So we can do people.filter, and here we can check everyone's ages. Let's just we can check that everyone is equals to or over 18. So what this bit of code does is when we do .filter, we're now saying filter out anybody who does not meet this. So anyone who isn't equals to, which way around is this? I always forget that. Everyone who's not age is not equals to 18, we want to filter out. Okay, great. And just a quick side note, Kotlin has a couple of syntactic sugar things here where if your method takes a lambda as its last argument, you can omit the bracket. So we could put brackets here, but you don't have to. In fact, Intellij will even complain at you and underline it, and we can just do that. And the other one here is we've got an implicit type here, it. Now, it refers to the person that we're filtering on. It's just it's automatically cast to whatever variable is being passed in, so we don't need to do p arrow person and just do p.age and all that. You can just do .it, and you're kind of encouraged to do that if you're writing Kotlin or this kind of style. Great. So we filtered out anyone whose age is below 18. Then we want to map data. So this is transforming data from one form to another. We want to go from a person to a person's name. So we want to map it.name. So we're just transforming data here. And finally, we want to perform an action. We want to perform a side effect. So for this, until this point, we're returning a list. So this map would return a list of strings. But now we want to perform a side effect, not return anything. So we can do for each, print ln, and just do it. And this should print out Rowan and Oliver, unless I've screwed something up. And if we play this, it prints out Rowan and Oliver, which is great. And yeah, this sort of stuff, it's extremely common now. I use it constantly. It's really handy. It is in other languages. Kotlin just sort of cleans it up a little, makes it nicer, and it's something that you definitely worth knowing. There are a lot of methods here. I'm not going to show you any more because there's a lot, and honestly, even I don't know what all of these do. If we go through here, we've got all sorts of things. I definitely encourage you to have a look, see what there is, and see the kind of operations you can perform on data, because there's some really cool stuff in there, especially about transforming data. Okay. Sorry, I'm going to be doing a few questions at the end, so if you can save your questions for then, that would be great. I think until now, we've mostly done stuff that Kotlin, it's not unique to Kotlin. Kotlin might do it really well, but it's not something that like only Kotlin can do. But there's a couple more things that Kotlin does that almost no other language, certainly no other popular language does. I'm just going to go into one more thing here. Now is going to be the time I'm going to find out that actually the latest TypeScript edition does this. But we'll just have to see, right? And this is something like infix functions, which are just a really cool little feature, I think. So let's just add a function onto our person, and we're going to call this says. It's going to take a message, which is a string. And I'm going to use the shortened method syntax here just to show it off, where you can just do equals, print ln, and let's do name. This has to be in quotes. So we go name says message. Awesome. So we can call this, acts as a perfectly normal method, nothing fancy here. Let's just get rid of this stuff. Val Rowan equals person. Great. So we go comma. And if we play this, oh, my linter is complaining. There we go. And if we play this, we just says, Rowan says Kotlin is the greatest. And I do. But let's make this just a bit fancier. This is all fine and good. But it's, it is still code. Someone unfamiliar with this, it's like Rowan.says, pass it in. It's reasonably obvious what it does, but it's still not the clearest. So we can add a little thing here called infix. And this doesn't change something immediately. If we play this, nothing changes. Rowan says Kotlin is the greatest, and I still do. But we can do something cool now. We can take away this dot, and we can take away these brackets, and we can just write this as pretty much English. Rowan says Kotlin is the greatest. If you name your methods right and have the right kind of arguments here, you can pretty much write English. I think there's even a like a Kotlin poetry thing or something like that, where you try to get code that solves a solution, has sensibly named methods, but is entirely written in this style. So you could like write poetry or a story in this. And I just think that it's maybe not one of Kotlin's killer features, but it's definitely an awesome one. There's a lot more stuff we want to go into. I think we are coming up on time now, and I don't want to overrun too much. There's a lot of Kotlin features we haven't gone over. We haven't gone over like DSLs. Kotlin lets you build domain-specific languages with a combination of your infix functions and your those lambdas I showed you with .map and .filter. We haven't gone over extension methods. There's tons of stuff in collections we can go over. Like it really is a deep language. It had a lot of features when it came out in, I think, 2017 might have been the first release, maybe a bit before that. And they've just kept adding stuff since, and it is some fantastic stuff here. But we don't have quite a time for that today. So I'd just like to hit my conclusion now and just say, hopefully I've convinced you to give Kotlin a go. It is an awesome language. It's a very modern language. It's actively being developed. It's certainly dragging Java into the modern day. We'll just hope Kotlin can keep ahead of there. It can run on pretty much any domain. So if you're a front-end web developer, you can use Kotlin. You can compile it to your JavaScript. You can do anything there. If you are even if you work on embedded stuff, you might be able to get the native working. If you work on servers like I do, then it's pretty much purpose-built to run on the JVM on servers. And it really is one of the fastest growing languages around. It's especially in Android, where I think it's overtaken. I think 60% of Android developers use Kotlin nowadays. Like, it's massively exploding as a language. And I just think it's a really good pick if you want to pick up another language that there are definitely jobs available into it. We have some of them. It works with Java, and it's got interesting parts to it that other languages just don't always have. Okay, so if you have any questions, you can ask them now, and I'll go through and answer them. I think there's one there already, which is, what's the Kotlin-ish way to get access to the array itself in the map in JavaScript? So I think there are extra methods where you can do this. I've forgotten exactly what it is. There are methods, for example, where you can build up another array within that, for example, reducing. If you use immutables, I think you can just assign it to a different variable above and just access it the way you'd access any other variable. But I think Kotlin tries to encourage you to structure your code in a way that is about transforming data and not changing it. So ideally, you should be structuring everything in a way that you don't really have to access the original one, and your data structure is set up in a way that you can just go through, perform your operations, and transform your one list into a second list instead of changing any data in there. So yeah, I hope that answered your question. Is there anything else? Do I need to go under the Q&A tab? Yeah, Jody, just to let anyone on the video know who can't see the chat, Jody says she works with Android devs and the code always looks a bit overwhelming, and that seeing it without Android makes it a lot more friendly. I think that's a problem I ran into when I was learning Kotlin. When you search for help online, it's almost exclusively Android stuff, or at least was a few years ago. Since Kotlin's taken over a little, not taken over, but it's gotten much bigger in server side, that's gotten a bit better. But I really think Kotlin it's separate from Android. It works on Android fantastically, but there's a lot of mix-up there, and I think that can scare a lot of people away from the language. I know it definitely did for me for a while. Since when I first learned Kotlin, it was with a team lead of mine, and who was very much into Kotlin and didn't work on Android at all, or at least didn't at the time.